let's go to liquid 152, maximum product subarray. For this question, it gave us an integer array that is nums, and let's find the maximal product subarray. So we know we'll find in the nums array, it can be positive or negative number, right? So we can iterate those kind of nums array. What we want is that we have two variables. For example, dp, we have dp 0, 0, right? Which will be means the number index 0 will be included. What is the maximal product? And dp 0, 1 will be the index 0 included. What is the maximal product? And also we have dp 1, 0. That means for the element at index 1, the subarray end with not included should be end with a subarray end with 1, which the maximal product, so it will be, right? And also we'll have dp 1, 1, right? It will be the subarray which index 1 is included, is end as it's an end element, the minimal subarray. And in the end, we just find the dp n minus 1 there, right? So we find the maximal values here. That is our result. So there is some kind of transition conditions for every dpi 0. We know it can become coming from three kind of scenario. Is that for example, it have a dpi minus 1, then 0. That is means the previous for the nums I minus 1 is also included and multiplied by nums I, right? And also it may, for example, this may be a negative number. There will be dp minus 1 1 multiplied by nums I. And in the third case is that we just do not include this. We just start from this nums I. So it will be just a nums I. So it will compare the biggest of these three. Okay. So the same thing for the dp 1, right? The minimal. It will be also coming from the three cases. That is, if it is the biggest, right? And possibly this is a negative number, it will be a very small number when do the product. And also it may have the dp minus 1 multiplied by current number. And the third case is that we only include the current nums I. So the transition function, for example, we have dp 0. We'll use this one as the biggest, because max dp minus 1 0 and multiplied by nums I, and dp minus 1 1, this smallest, multiply nums I, or we are just nums I, right? And for the smallest, we also have this kind of conditions. Right. So, but we will have mean. So this will be our transition function. So when we write this question, because actually every element is just depend on the previous element, right? And also current number. We can actually use the max and mean variable to write. So we can have int max equals nums 0, and the mean equals nums 0, right? So let's say for int I, let's get its length. Int I equals nums of the length. For int I equals 1, I is smaller than n, plus plus. Let's say the max, right? Max will be equals to max dot max. Nums. The max multiplied by nums I. Mean multiplied by nums I. And we'll have another measurement. Max nums I. Be like this, right? And also we'll have the mean be something similar. So this will be something like the transition function. But here, there is some kind of problem. You see, this max and the mean already changed. This max already changed, but it is used in the second function, right? So we can possibly use current max. Okay. And we'll say result. Otherwise, this value changed if you calculate. We want to max that is in the previous one, right? So nums I minus nums I, right? Int so we'll say we'll have a result, right? Int result equals integer at the beginning, so at least be max, right? So result equals max dot max, current max, and result, right? And after this, we'll have max equals current max. And in the end, we just return result. We can also use the rolling array, the same thing, but here with the two variables should be fine. But one thing to take notice is that this max, right? If we set them value to this max directly, this calculation will be wrong because the minimum will use the previous iteration's max, so it will have issues. That's a problem. Num psi S max mean equals that should be mean. Sorry, this should be mean.